Hello and welcome to Unit 2. We're going to start on 2.1 notes, so make sure that you are on this page. It looks really similar to 2.2, if I could find it. They look really similar, so make sure that you're on the multiplication one. Okay. So our I can statement is I can develop rules for integer multiplication. Oh, so close. Someday, I'll figure out how to make those not as long. Okay, so we did adding, we did subtracting. Now we're moving into multiplication and division. Woo. Okay, so ways to show multiplication. We're going to use the example 3 times 4. Are 3 with parentheses 4. Now, I know this might throw some of y'all for a loop, so let me find some scratch paper. All right, here's some scratch paper. Okay, so before, parentheses can also hold negatives. Okay, that doesn't mean subtracting, that just means it's holding, giving it a hug, the negative 4. Okay. It also does not mean that you do that number first. Nothing's happening, it's just holding that 4. So parentheses can mean a lot of things. So in 3 plus negative 4, you don't have to write this part. Okay? This plus tells us what we're doing. These parentheses are just holding that negative 4. And parentheses like this is telling us to add within the parentheses. Okay? Parentheses are also a way to show multiplication. So when we have nothing in between them, there's a little invisible times multiplication sign. All right, tangent over. You can also have numbers like this. 2 sets of parentheses touching each other. Or we also use a dot. Okay. So since we're getting closer to starting some algebra topics using variables, I won't use this x to mean times anymore. I'll start using the dots or the parentheses. Okay. So down here it says, use the table to find negative 4 times 3 and negative 4 times negative 3. So these tables are going to help you arrive at your answer. Okay, so 2 times 3 is 6, and 1 times 3 is 3. So from 6 to 3, I'm actually subtracting 3. And from 3 to 0, that's minus 3. So each time I go down a step, I'm going to subtract 3. 0 minus 3 is negative 3. Negative 3 minus 3 is negative 6. Negative 9, negative 12. So each time we subtracted 3. Okay. So from negative 12 to negative 8, I'm adding 4. From negative 8 to negative 4, I'm adding 4. Okay. So I want you to pause in a second and fill in the rest of the table and explain. So go ahead and pause and fill it in. So each time I add 4, negative 4 plus 4 is 0. 0 plus 4 is 4. 4 plus 4 is 8. 8 plus 4 is 12. And I added 4 each time. I saw the pattern. Scoot him over. You'd think I would have figured this out by now, y'all. More scooching. A little more scooching. Let me rearrange on my desk. Here we go. All right, so I want you to think about what do you notice, so on this guy, about factors, about products. Okay, product is the answer to a multiplication problem. Okay, so what do you notice about these guys whose factors, so the two things you're multiplying together, are a positive and a negative? So looking at a negative times a positive, what was the answer? A negative times a positive, what type of answer was it? Positive or negative? So I'm noticing factors that have different signs so one positive, one negative, will have a product that is what? What was our answer each time when they were different? It was negative. Okay. Let's look over here. What do we notice about signs of products whose factors are both negative? So we had a negative times a negative. What type of answer was that? A negative times a negative was what? So I'm going to start my sentence. Factors that have the same signs, so they're both positive or they're both negative. So here was a negative times a negative, and I had a positive answer each time. We'll have a product. So every time I multiplied 2 negatives together, I ended up with a positive answer. And we can double check. 2 and 3 are positive, and I ended with a positive answer. 1 is positive and 3 is positive, I ended with a positive answer. Okay, so it works every time. And we kind of already did the next step within that step. So it says make a conjecture. That just means like a rule about the sign of a product whose factors have the same sign. So factors with the same sign will have a product that is positive. Okay. And it says, make a conjecture about the sign of a product whose factors have different signs. So a product whose factors have different signs will be negative, is what we should have seen. Oh, sorry. Scooch it over a little bit. My bad. All right. And then, just to help the message sink in, we're going to simplify it a little bit. So when you're multiplying integers with the same sign, so that's a positive times a positive, or a negative times a negative, we'll have a product that is positive. Which means that integers with different signs, so a positive times a negative or the other way around, we'll have an answer, a product, an answer that is negative. All right, so let's put this into action. Here we have 3 times negative 10. First of all, I'm going to do 3 times 10 is 30. We have a positive times a negative. Those are different. So our answer, different, is negative. Over here, negative 8 times negative 4. 8 times 4 is 32, so it's going to be some type of 32. We have a negative times a negative. Those are the same, so your answer is positive. So there's positive 32. Negative 9 times negative 7. 9 times 7 is 63. Here we have a negative times a negative. Those are the same. So your answer is positive. Last but not least, negative 11 times positive 12. Is that 132? 11 times 12 is 132. We have a positive times a negative, a negative times a positive. Those are different. Different signs is going to be negative. So negative 132. And that's it. If you're having a hard time remembering, I know it's a lot. It's a lot to mix in with our addition and subtraction rules. Totally get it. Just go through, read up here. Same sign is positive, different signs negative when you're multiplying.